Welcome to this lecture on rolling element bearings in the course Advanced Machine Elements. My name is Jens Hadell and I am one of the teachers in this course. Today I will be discussing rolling element bearings, and the lecture is divided into three different parts. In part 1 I will give you a brief introduction to rolling element bearings. I will discuss the pros and cons with rolling element bearings compared to journal or slider bearings. And then I will give you examples of common bearing types that you can come across. In part 2 I will go into the bearing materials, into the lubrication aspect of the bearings, then move on to the surface roughness and subsurface stresses, and finally the friction mechanisms that you can encounter in rolling element bearings. And the last and third part I will be talking about wear and failures of rolling element bearings. But let's start with a brief introduction now. The general idea of a bearing is that it should be capable of transmitting forces between, for instance, a gear and the gearbox housing, and it should also enable relative motion between, for instance, a shaft and the housing. Now, the motion that you can come across will be either linear motion. It can also be a rotating motion, which is probably the most common type that you encounter when it comes to rolling element bearings and shafts, for instance. And you can also have a reciprocating motion, which is a back and forth type of movement. And this can be either oscillating, reciprocating in the rotational mode or in the linear mode. If we look at the design of a rolling element bearing, you basically have four main components in the bearing. You have an outer race and an inner race, and in between these two you have the rolling elements. In this case it's a sphere or a ball, which makes this a ball bearing, but it can also be a cylinder or a roller. Then you have a fourth component known as a cage, which you see right here. Now the cage is designed to separate the rolling elements from each other and also to equally distribute them in the bearing. And as I mentioned, the shape or the geometry of the rolling element decides whether the bearing is a ball bearing, in which you will have balls or it will have spheres, or it's a roller bearing, where you have rollers or cylinders as the rolling elements. And the general name for all the different type of bearings is rolling element bearings. Now, the pros of having rolling element bearings compared to slider bearings would be that you have low friction during startup and during operation. You don't have to overcome any initial high friction to get started, and since you have mainly a rolling motion in the bearing, you typically have very low friction during operation as well. It can also carry a combined axial and radial load at the same time, whereas for instance in a slider bearing you would need one bearing to carry the radial load and another one to carry or take up the axial load. The rolling element bearings are also less sensitive to inconsistency in lubricant supply compared than to a journal bearing, for instance, which relies heavily on a continuous lubricant supply to be able to maintain the lubricating film in the bearing. You typically don't have any stability problems and no issues with starting up at low temperatures. And another the benefit is that you can also contain the lubricant in the bearing. When we're talking about greases, you can fill the bearing with grease and you can put seals on it, and that will give you what is known as a lubricated for life bearing. The cons of rolling element bearings then would be that it has limited life. The bearing will suffer from fatigue eventually due to the cyclic loading nature of the rolling element versus the races. It will also require a slightly larger radial mounting dimension compared to a bushing or a journal bearing that is very thin or relatively thin. This one has a larger dimension in the radial direction. It also provides poor damping since there's no thick lubricating film to separate the surfaces in the bearing. It's typically also considered to have a higher noise level and more vibrations compared to sliding bearings. And it also puts higher demands on aligning the shaft with the housing, for instance, that there shouldn't be a misalignment between these that introduces any bending stresses into the bearing. And finally, it is also susceptible to stationary vibrations, but I will come back to that specific point later on in this lecture. Now, this picture shows you a number of different common bearing types. We have a number of different ball bearings, we have a number of different roller bearings, and finally also some axial bearings. I will go through each one of these and give you some examples of how they work and where they might be found also. Starting with the deep groove ball bearing, this is probably the most common rolling element bearing that you can find, and you can find it anywhere from machines that you find in your kitchen to cars, any kind of automotive vehicles, trains, aircrafts, anything. It's very, very common and found almost anywhere. It has the benefit of being able to take radial loads as well as axial loads at the same time, since you have what is known as a deep groove, so you cannot really push out one of the rings relative to the other one. It's also very often provided with a seal and filled with grease, which results in what I said is lubricated for life. You basically seal off this part and the other side after you fill it with grease. Then we have what is known as a spherical ball bearing. This bearing is able to take misalignments or compensate for misalignments due to the spherical shape of the outer race. So you can see that this one has a curvature right here, which means that this, if you picture a shaft right here, can actually be misaligned compared to this surface right here, and the bearing will still work. But because of the shape, it also has a reduced load carrying capacity, because the contact becomes more towards a point contact and elliptical contact, and the contact area reduces, which gives rise to higher contact stresses. Another type is the angular contact ball bearing. It can take both radial and axial loads, but this one requires an axial load to work, otherwise it would just fall apart. So you need to apply a load in this direction to keep the bearing in one piece, basically. There are also 2-row angular contact ball bearings, which can also take up large bending moments. For purely axial loading, there is the axial ball bearing. It can only take loads in one direction, in this one shown here. If you have a 2-row axial ball bearing, it can take loads in both directions. Now, this is a different type. This is a taper roller bearing, and probably what is also considered to be the second most common type of rolling element bearing after the deep groove ball bearing. Just as the previous bearing, it also requires an axial load to not fall apart, but it can also take a relatively large radial load, which makes it a highly useful bearing in many applications where you have a combined loading situation. The spherical roller bearing is similar to the spherical ball bearing, where you have a curvature on this inner surface of the outer race, enabling that the bearing can accommodate misalignments in the system. A cylindrical roller bearing can take radial loads, but it can also allow axial displacement, meaning that this one is allowed to slide slightly relative to this one to compensate for instance, expansions in the system that the bearing is mounted in. Finally, we have SKF CARB bearing, and CARB is an abbreviation for Compact Aligning Roller Bearing. This is a bearing that can accommodate many different loads, and it also accommodates for misalignment, like you see here, and it can also accommodate for an axial displacement, and it can carry a regular radial load as well. So it's a very versatile bearing that can be used when you have a loading situation that requires the ability of the bearing to compensate for this in some way. And by that, I thank you for listening to part 1 and hope that you will enjoy part 2.